Good morning, everyone. Thank you very much for coming along today to my presentation. I am the Chief Exec of Zonefox. Zonefox is we call it a big data solution. We'll find out why in a couple of slides. And Zonefox basically is a spin out from Edinburgh Napier University. We spun out here about 5 or 6 years ago. And Zonefox helps our customers with endpoint detection and response. So in the same way that Carbon Black and Silence and CrowdStrike help various individuals track down malware, we help our customers track down what humans are up to on their endpoints. And our customers range from video game developers through to pharmaceutical companies, microelectronics manufacturers, people operating in the US healthcare space, online gambling and finance. So why do we call Zonefox big data? Well, we stream what we call events from the endpoints. On average, we stream about 300 million events per day, per organization. So there's a fair amount of data that we stream. An average customer database has about 1 trillion events in it. And taking all of this into consideration, we need to produce, process, and inform them in a timely basis as to what's going on in their organization. And the net effect of all of this is that we like to talk about protecting IP. So, for example, an individual who's about to leave the organization might take plans with them, for example. We talk about staying compliant, so regulatory issues, for example. If you're working in the US healthcare market, for example, you need to make sure that personally identifiable information isn't accessed by those who aren't permitted to access it. And then we talk about maximizing security. And that's really around our access control set up properly, our existing controls working properly, all the things that you've put in place in order to stop people from doing things working in the way that they should be. Now, the reason why I presented a couple of slides with lots of numbers and then the net effect is that there's a lot of magic. Well, I'm not going to call it magic, our developers will be really upset with me. There's a lot of things that go on in between this. What you see from today is that you've been presented with an awful lot of numbers. I've seen loads of numbers up on the screen about billions of events and millions of things flying across the network, petabytes and zettabytes, and that's fine. But what we learned from building Zonefox is these aren't really the things that matter to our end users. So what I'm going to do today is talk you through some of the lessons that we've learned from building Zonefox, some of the big data lessons around how to process and how to really get through this data while making it meaningful for our end users. And hopefully there'll be some interesting tidbits in there for you in terms of how you may decide to roll your own solution should you want to do that. And it's a lot of fun. Highly recommend rolling your own big data solution. So what did we learn? From both a theoretical and practical perspective, I'm going to give you an overview. But first, let's do some theory. So let's go to Wikipedia and let's get a definition of what big data is. So big data is a term for data sets that are so large or complex that traditional data processing applications are inadequate. So what do we mean by this? So if we think about the 300 million events that we generate on a daily basis per site, if we stick that into an Oracle database, it's probably going to fall over fairly quickly. We have a set of data structures that are fairly consistent, but there's a lot of variety within that data. If we're going to scale these Oracle servers, then we need certain licenses, we need certain capabilities. So if we think about the traditional way of storing, transmitting, and analyzing data, it's not going to work for these very large volumes of data. But big data is being used across a number of different sectors. So Netflix, they've got a Hadoop platform. Apparently, if they started to use that effectively, they could target and lower prices for certain customers who only view certain items. Really cool, really interesting. We can try to predict the weather. Certain areas of the world, this works a lot better than others. A lot of big data analysis going into things like climate change, for example. We can analyze what people buy, therefore provide them special offers. Or if your target, inform a pregnant teenager's father that she's pregnant. In a now infamous case, Target sent some literature about baby care products to this teenager's home, and quite rightly they predicted that she was pregnant because she's starting to buy products at Target that were highly indicative of someone who's about to have a baby. Her father wasn't best too pleased, but it shows the real power of these techniques. And of course, healthcare. So big data capabilities and techniques are used in healthcare in order to help us analyze things like spread of disease, spread of epidemics, large-scale data sets in order to help us analyze the data from, say, cancer trials, for example. In order to highlight really what we've learned, I'm going to quickly go into a bit of social media. So I'm going to talk about Twitter versus Facebook. So who here uses Twitter? Who here uses Facebook? Okay. Twitter and Facebook are huge. They're incredible in terms of their processing powers and capabilities. And we sometimes compare ourselves to Twitter inside of an organization. So where we deploy our servers, we can, in terms of the number of events, we generate 300 million per day, which is fairly similar to what Twitter generates globally per day as well. So if we have a look at some of the numbers, again, we'll start with the numbers, but this isn't really the important part. Twitter claimed to have 332 million active users, goes up and down. They've had a lot of problems recently. And between 300 to 5 million tweets per day. There's been a recent controversy about whether this is an accurate number or not. They're not too keen on releasing their data at the moment, as they're facing some significant challenges, which we'll go into in a minute. If we look at Facebook, they've got 1.5 billion active users. And every 60 seconds, they've got 510 comments, 293,000 status updates, and 136,000 photos across their platforms. People talk about the V's of big data, so velocity, volume, and variety. These platforms deal with all of them. So it's a high volume of data. They need to have a high velocity with regards to it being meaningful, actionable at the right time, for the right people, in the right way. And there's a huge variety of different information types. Now, they're fairly similar platforms. They've probably got fairly similar architecture to a certain degree. They're text-based. You can post videos, you can post pictures. But if we have a look at a couple of graphs, we start to see the difference in what I think is usability and the key differences between the platforms and what they've got right and what they've got wrong. So this graph from the Pew Research Center highlights user frequency. So who's using Twitter and Facebook on a daily, weekly, or less often basis. And as we can see, Facebook wins here. If we have a look at the second graph, which is number of apps, minutes spent per app for time of day, it's clear to see. Do you need me to fix this screen? Is it really annoying? Let's see if we can do something about this. It's clear to see in that particular example that Facebook wins. So Facebook has about 50 minutes per user per day on that particular app, whereas Twitter only has about 10 minutes per user per day on their app. And the reason for this is, who likes using Twitter? Does anyone here actually like using Twitter? Hands up, please. Okay, so out of the people who do use Twitter, we've got about 4 or 5 that actually like using them. Do you not feel as if you're drinking from the fire hose? How do you feel about the onslaught of information that you get on a daily basis? Do you like that? No. Do you wish that they do something about it in order to make a transformation, make it more actionable? So Facebook used to be a lot like Twitter. It used to be a pure fire hose from your mates, from your relatives, from whoever it is, in order to grab your attention. But what they've done is they've started to, in the past few years, refine that. So it's far more curated content. And I would argue that Twitter has got a lot of things wrong in terms of the way they blast data at you. If you look at the Facebook website, there are tools within Facebook that you can use in order to curate, gain access to data. Thank you very much for that. And self-filter. So you can get alerts from certain people, you can get alerts on certain events, so on and so forth, and you don't feel quite as overwhelmed. Even though they're dealing with large amounts of data, in fact, Facebook's dealing with a higher amount of data, they managed to get it right. And this is borne out by some of the numbers. Twitter used to be worth $40 billion. They're now worth 10. I'd like a company worth $10 billion, but the market cap has gone down because they have significant issues in terms of their usability and the value they're bringing to their audience. Facebook, on the other hand, is worth $250 billion. It's a far more effective marketing and advertising platform. So I would argue that the creators of Facebook have fundamentally got their audience right, they've managed to manage and curate their data in precisely the right way in order to provide a fantastic advertising platform. So what did Facebook get right? So we need to think about meaning and focus here. And we did an awful lot of work with some of our first customers on what these things meant to them. So in terms of meaning, data is not information. Our CTO, Matt, who's sitting in the audience, talks about this an awful lot. And he's right. We used to be like Twitter as an app. We used to blast information at our users, and they didn't find it useful. We have ways for them to filter, be alerted, a bit like Facebook, but we just blast information at them. It was uncontrolled, and so our users found it really, really difficult to gain meaning out of it. And then we've got signal to noise. Once they do find an interesting piece of information, how do they mine into it? How do they get the valuable information from the tool in order to gain the valuable insights? So for example, if someone's just been discovered to be moving a file from a network location they shouldn't have access to, how can you quickly understand what else they've been doing around the organization? And we have to provide these tools in a timely manner. Second one is focus, and that's where we get into some of the aspects around volume, velocity, and variety. So volume, the amount of data. Facebook cuts down on the amount of data that you're exposed to. The velocity of data, there are real-time updates, but it's not quite as bad as the fire hose that Twitter is. And variety of data, they fuse this together in certain ways. And this is where we get to the fourth V, value. All of these things must be combined in a certain way in order to provide value to your end user or customer. In practice, this is where the rubber hits the road in terms of what we do. So we have an architecture. We have an endpoint agent, very lightweight, collects certain amounts of data. We have components that stitch together in certain ways, but this really isn't the important part of this. I mean, we've got a fairly classic big data backend. We collect a very simple event model, so it's very focused on one problem, which is what are your humans up to within your organization. There are some side effects, so we can do things around what processes are up to, but fundamentally, these are the features that we've pulled out of the data set. We can do cool things with them. So we can store them really easily. We can compress them really easily because it's really simple data. And we can run machine learning techniques on them. Because we've got a small feature set, we can run these machine learning capabilities really, really quickly. So what does this mean? So thinking about, okay, we've got millions of things happening. We've got lots of storage. What does this mean for our users? So we're able to tell when Bob in HR starts acting like Alice in engineering. So we can tell when Bob has stopped acting like himself. We can tell when Bob has stopped acting like the peers in his group. So we can compare his activity against everyone else's activity. And because we've got a really small data model, we can do this very quickly indeed across the large amounts of data that we gather. Because we've got a large amount of data, we can do some really interesting long-term analytics on it. So it's not just small periods of time and space we're looking at. We can store 6 months, a year, 6 years, depending worth of data, depending on how much our customers want to spend on hard disks. When Alice is thinking of leaving the organization, so there are certain steps an individual will go through before they hand in their notice. Should they be wanting to take data with them, they'll start doing a bit of reconnaissance. They start looking through areas they typically won't look through, and then they'll start putting things onto USB drives or folders. And then Eve uses shadow IT out of frustration. We were talking about shadow IT earlier on, and this is the majority of accidental security breaches or lack of training that we see in an organization. So we see an awful lot of users just want to get their job done. They use whichever tools are available to them. So it's Friday, it's 5 o'clock, they want to share that presentation with a partner, so they're going to stick it in Dropbox because there's an email limit of, say, 20 megabytes, so they can't effectively email it out the organization. And for this, we've implemented a very, very simple correlation engine, which provides these insights to our end users. In terms of practically building one of these things, there's still a lot of challenges. So in terms of the maturity of the technology, our developers talk about breaking changes every 2 to 4 weeks due to technology updates, fundamental changes in the technology. There are quite a few versions that come out in rapid succession. We stuck a line in the sand only to realize that that version wasn't good for us anymore, so we had to do a lot of updates and changes. One big data solution usually solves one problem. If you're going to take one thing away from this presentation, that's absolutely it. It's great having all the data in the world, but all that data can't solve all your answers unless you have very pointed analytics and capability to understand what you're after. And you soon get very, very lost. In terms of speed and consistency, this is about read-write capabilities of some of the technologies that we use. So in the old relational database world, you'd have consistency, but that's potentially not the case. So that's a trade-off in terms of the technologies that are out there nowadays. We find it very hard to hire big data developers. It's hard enough to find developers as is, so we have to bring people in, train them up. If they're already trained, great. They know the basic techniques, but the first version of the software we built with guys who knew their relational databases, and in order to get their heads around things like Cassandra was a real challenge for them, and the talent pool is pretty small. Security in big data is actively developing, so you will have to configure an awful lot of things out of the box, so access control, encryption, so on and so forth. It will not be done for you, and you need to pay special attention to that in terms of how it fits into your broader security architecture. And additional features, so things that we may be used to from, say, a Microsoft suite of tools are typically bolt-ons or add-ons, and these can be incredibly expensive. Big data is a big hammer, and with hammers, you can view every problem as a nail. But my advice to you would be to make sure that you're targeting the right kind of nail, you've got the right kind of analytics. And if you do, big data can be incredibly successful for your organization. Thanks for your time, and I'd like to answer any questions you may have.
Any questions, please? Yes.
So I have actually two questions. One question you might not want to answer. I wonder if you would recommend what data analytics methodologies you would use to do anomaly detection in users' behavior on the endpoint.
So the question is, would I recommend to do it, or?
What methodology would you recommend to use to do anomaly detection on the behavior of a user?
Right. We're just working on that right now. So it's not something I can answer from probably a fuller capability. There are two ways in which we're solving it. One is purely rules-based, so there's an awful lot of stuff you can pick up from a defined security policy across the organization. So for example, you hook into Active Directory, you've got what should be a logical snapshot of access controls, and then you can model what users are doing really simply in terms of are they actually following those particular access controls. And then on top of that, there's the machine learning capability, which I can't really go into right now.
And the other question was, so you run it in an agent model. Are you concerned about performance and locking down the endpoints?
Yes. Absolutely. So one of our customers is Rockstar Games, and they need to compile their games on a nightly basis. So one of the go, no-go points for them was, what's the performance hit on the endpoint? And I think this goes back to one of your considerations, which is how deep do you go in terms of the data you collect? One of the things you could do, for example, is turn on all auditing on the operating system, which would be great because you have to have lots of data, but your system would fall over. And so when it comes to these point solutions, there's a trade-off between quality and quantity of data. And so we went for this smaller, 6-factor model based on the fact that you can identify certain things with it. It's pretty effective over a period of time, and you can do that long-form analysis with it, but it won't have a huge impact on the endpoint when you're collecting it. So absolutely, huge consideration of ours. That combined with the fact that we don't want to push policies, so we want to collect as much data as we can and do the analysis centrally, gives us a better model of operation for when people, say, in the field. So salesperson on their laptop in, say, Germany. they're out with the network. Typically, you don't have insights into what's going on. We're able to gain those insights through lightweight data model and using existing protocols like HTTPS, for example.
Anyone else have a question? Ooh, I'm sure. Yes, please.
Hi, you mentioned you find it difficult to find developers with big data experience. Where is it you typically find people to train up?
Gumtree.
Yeah, we found lots of people on Gumtree. I mean, anywhere really. I mean, for us, it's why do you hire someone if they're, they can solve problems, you like working with them, and they're people, that are up for the challenge. I think it's characteristics more than skill sets, and if they've got those characteristics, they'll be willing to learn.
Yes, question.
Hi, Jamie.
How you doing?
Presentation. Where do you think the development goes next? Do you think it's more focused on the user profile or the profile of the user environment? So what could be going after them, or what they might do, right or wrong? And is there anything in terms of larger organisations, in terms of they have policies, acceptable use policies, employment legislation, etc.? Do they have any concerns about the monitoring of the user?
So the first part, that's about the user environment, and you said something about going after them. What do you mean by that? As a malware or?
As in malware.
Yeah. Yeah. We can do malware detection. We did a bit of work last year, and the type and quantity of data we collect is pretty good at detecting when a bit of software starts acting differently. We decided not to go down that route purely because it's a saturated market. There's lots of people doing it. So I mentioned Carbon Black and Cylance, and all these guys are doing it. And we live, neatly alongside those guys. So coming next, yeah, sure, we could do that. And in fact, we helped one of our customers recently with a ransomware infestation. So it's about that detection and response piece that's useful alongside the human element. And then your second question was about regulatory issues and the environment of monitoring people. This is no more invasive than email monitoring. In fact, I'd say email monitoring is far more invasive. Say deep packet inspection is far more invasive. Because we're collecting effectively metadata about file interactions and process interactions, there's very little in the way of personally identifiable information in there. So typically an organization will have a blanket. If you use the system, you permit the use of monitoring capabilities and technologies. Now, the result of that is you may not be told exactly what's happening. So your emails are already getting scanned. You've probably got network traffic that's already being inspected, and this is a far lighter form of behavioural activity than that.
Could I just, sorry if you wouldn't mind, one follow-up question. Sure. In terms of industry sectors, where do you think to grow? For example, what about the health sector, because it's so sensitive in protecting personal data especially?
You're absolutely right. I would say it would be geographically sensitive. So the UK, we know it takes a while to sell to the NHS. And for us, it's about quicker wins to build up that body of customers, which is why we've got a client in the US healthcare system, because there's regulatory, it's easier, there's eye-watering fines associated with losing data, and it really depends on the regulatory environment.
Thank you. Thank you very much.
Thanks for the questions.
One final question, please.
Just a follow-on question from what you mentioned earlier. You talked about it being no more invasive than email scanning or deep packet inspection, etc. The type of data or information and intelligence we're actually getting out of this big data solution. You talked about knowing when Alice wants to leave the organisation. Where does that stand from a privacy perspective in terms of organisations and a user's right to privacy?
Yeah, absolutely. Again, I refer you to my answer about the policy that you sign up to when you join an organisation, and we're all monitored within our organisations. And my right to privacy, okay, so if I bring my own device, probably got some photos on there, some images, but I would say that's less invasive than having my network traffic analysed for Facebook updates, for example, or web proxy data, for example.
Just a lot of the email analysis and traffic analysis is about detecting keywords
Yeah.
and rules to trigger. This is building up a profile. which is probably more
Yeah.
useful in terms of performance reviews or employment
Yeah.
law, etc.
Absolutely, and one of the first things we thought about was, hey, this could be used for performance purposes. You know, you could do that with, I know of a case of someone whose web browsing data through the web proxy was used for those purposes. And I think that's where we get into, well, you need to have a blend of workers' rights versus the security of the organization. And there's never an easy answer to these things, but any technology can be used for that particular purpose. And that's when I think it's a blend of policy institutions. So, for example, the organizations that provide workers with information on what their rights are, and also sensible management as well. And there are good organizations and bad organizations. The good ones will use it for that, and bad ones, well, I mean, you look at things like awareness software that literally scrape the screen. So you've got keystroke analysis, you've got website analysis, you've got video recordings of what the user's up to. You've got the modern Dickensian workhouse, effectively, all within an electronic environment. And some people work for those organizations. Some people have no choice around that, so huge moral arguments around that. Thanks.
Okay, thank you very much indeed.
Thanks, Adrian. Thank you.